Okay, so hello everyone. My name is Agastya Devanantha Dharmawan, and my student ID number is F1D02410071. Today I'm going to present my final project, which is a parallel processing. And what I'm built right now is the weather forecast using a parallel processing with real-time data and using a PyCUDA. So basically, the way that I get the data is by using the Open-Meteo API, so I can get the weather data for free. This is all of the import. This is where I fetch the data, so on, like the location. I'm using a Mataram, and this is all the data that I get, so on, and I get the visualization of it, and yeah. Now, let's go to the parallel concept of my code. So, before diving into the code, let's establish our parallel point. And basically, in a standard CPU programming, calculations are done sequentially. Like element 0 is computed, then element 1, then element 2, in a linear way for moving average and classification rule. This sequential loop quickly bottlenecks, and on a GPU we solve this by configuring a grid and block of threads. We assign one thread to compute exactly 1 hourly data points, and by launching thousands of threads simultaneously, the GPU computes the result for the entire datasets parallel. Each thread identifies which data point is responsible for calculating its unique global index using a CUDA built-in block and grid variable. This is what I mentioned. So yeah, so let's look at the first task, which is the numeric processing. Yes, numeric processing. So for the temperature forecasting, here is our CUDA C++ device code. Notice the global void moving average signature, which indicates this function runs on the GPU. And this one, its thread computes its unique global index. After confirming the thread index, its threads process a sliding window of temperature data points centered at its index, sums the values, average them, and writes the output. And also we can see the code in the Python. This is the code, and yeah, we define a block size of 256 thread and calculate the grid size as this one, grid size, and it's divided by the block size. And also we allocate GPU buffer using the CUDA memory allocations. And it's copy our raw temperature from the CPU host to the GPU device using the memory CPI host to device. Yeah, and launch the kernel. Finally, we retrieve the smoothed forecast output back to the CPU via the memory CPI device to host. This one, yeah. So now I'm going to go to the text processing one. So actually, this is the yeah. And our second task, we create a classification for the weather. Yeah, and we want to read the several weather inputs like the temperature, humidity, wind, and so on. And in the classify weather, each thread extracts the atmospheric parameter for its assigned index. It then evaluates these variables against a set of classification rules. And for example, if the temperature is below 10 degrees Celsius, it assigns category 4, for cold. And if the humidity is over 85% and the clouds are over 80% and visibility is low, it assigns the category for rainy. And something like that. Just like before, we compute this on a 1D grid with a block size of 256. The Python host allocates GPU array for the sensor input and copies the data over, launch the classifier kernel, and fetches the result categories back to CPU memory. And these integer categories are then mapped directly to text label in Python. So we can see the result. Okay, so before that, I want to present you the result for the numeric one. Yeah. This is our result for the numeric one. For the numeric temperature forecast, the GPU computed 2.24-hour moving average, and this is the time for it needs to complete, right? And in our plot, the blue line represents the road temperatures, while the orange one and the green line show the parallel moving average. You can see how smoothly the GPU computes the smoothed forecast lines. Looking at the weather classification result, this one. Looking at the classification result, the GPU classified all of the 1,168 hourly data points in a mere 0.14 and 2 milliseconds. And this is all of the summary of it. And we can see it on the chart, we can see on a percentage breakdown, and yeah. And I think that's all from me, and thank you very much for your attention, and thank you.